Let's do Brahmanad. Om. Om. Shanti. 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 Swasta.
Good morning student. Today I will explain some tricks how to remember the element present in the modern periodic table. At first I will think about the group 1 element. The element present in group 1 are hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. To remember such type of elements, generally we use a trick. तमे मध्य चाहिए निजे निजे मध्य गोटे गोटे ट्रिक बाहर करिकी मने रखि परियो. Suppose I am thinking about the group 1 element. For remembering group 1 element, we generally use a simple trick, that is your Halina का रूबी से फ्रेंडशिप. This H indicates hydrogen, this Li indicates lithium, this Na indicates sodium, K indicates potassium, R and B indicates rubidium, C indicates cesium, Fr indicates francium. Similarly, think about the group 2 elements. The group 2 elements are beryllium, magnesium, calcium, strontium, barium, radium. To remembering such type of element, generally we use a short trick, that is your beta mange car sandro ba raji. Here B represents to beryllium, Mg represents to magnesium, Ca represents to calcium, S and R represents to strontium, Ba represents to barium, Ra represents to radium. Similarly, think about the group 13 elements. The group 13 elements are boron, aluminium, gallium, indium, thallium. To remembering such elements, generally we use a short trick, that is your Bal, Gangadhar, Indian, Tilak. Here B represents to boron, L represents to aluminium, Ga represents to gallium, In represents to indium, Pl represents to thallium. We can also use another trick, Baigan, Alu, Gajar, Inthal. As your choice, you can use any type of trick to remember these elements. Remember one important point, these are not belongs to your course of study. Next is your group 14 element. For remembering the group 14 element, generally we use a short trick, that is your chemistry gives short problem. The group 14 element are carbon, silicon, germanium, tin, lead. This C indicates carbon, this Si indicates silicon, this G and E indicate germanium, this S indicate tin, this P and B indicates represents to nitrogen, P represents to phosphorus, S represents to arsenic, S and this letter B represents to stibbium, Bi represents to bismuth. For remembering the group 16 element, we generally use a short trick. उससे तेरा पोल खोल दूंगा. Here O represents to oxygen, S represents to sulfur, Se represents to selenium, T represents to tellurium, Po represents to polonium. Like group 16 element, we also think about another tricks to remembering the group 17 element, that is your फालतू क्लास में बोरिंग इंस्ट्रक्टर आता. Here F represents to fluorine, Cl represents to chlorine, Br represents to bromine, I represents to iodine, and the letter T represents to acetylene. Next thing about the group 18 element. The group 18 elements are helium, neon, argon, krypton, xenon, radon. For remembering such type of element, we generally use a short trick, that is your Helena, Nena or Karina Xerox copy of Rani. Here He represents to helium, Ne represents to neon, A and the letter R represents to argon, K and the letter R represents to krypton, Xe represents to xenon, R and the letter N represents to radon. Next, I will think about the D block element. The first series, that is your third series, elements are scandium, titanium, vanadium, chromium, manganese, barium, cobalt, nickel, copper, zinc. For remembering such elements, generally we use a short trick, that is your school time very crazy, men फिर कोई ना कोई जाएंगे. Here Sc represents to scandium, Ti represents to titanium, V represents to vanadium, Cr represents to chromium, M and the letter N represents to manganese. Here Fe represents to ferrium, that is your iron, Co represents to cobalt, N represents to nickel, C represents to copper, Z and the letter N represents to zinc. Similarly, for remembering the fourth series elements, we generally use a short trick. यारा जरा निभाना, मौत तक रुकावट, राही पड़ी आग बुझ जाना. The elements are Y, Zeta, NB, MO, TC, RU, RH, PD, HG, CD. Next, for remembering the fifth series, generally we use this short trick. इसीलिए आरडी शर्मा की बुक में होते हैं मैथ के डिफिकल्ट सवाल. The elements are Sc, Rf, Dp, Sg, Bh, Hs, Mt, Ds. The sixth series elements are La, Hf, W, Re, Os, Ir, Pt, Au, Hg. For remembering such elements, generally we use a short trick, that is your lambda have horn, tantalize, wolfram and renal osmium irritates platonic golden mercury. Similarly, for remembering the lanthanide series element, generally we use some trick. First trick is your सेलिना और प्रीति ने डंडे से पमी और सीमा को मारा. सेकेंड ट्रिक इज यूरोप गया तो टीबी और डायरिया हो गया. थर्ड ट्रिक इज यूरोपियन टमाटर येलो और ब्लू. द एलिमेंट्स आर सी PR, ND, PM, SM, EU, GT, TP, DY, HO, ER, TM, YB, LU. For remembering the alternate series elements, generally we use some tricks. That is your थोड़ा प्यार उन पेरेंट्स से भी करो. सेकेंड ट्रिक इज पुलकित के आम कम बिके कल इस बाजार में. थर्ड इज फैमिली आमदनी में नो लड़ाई. द एलिमेंट्स आर TH, PA, U, NP, PU, AM, CM, BK, CF, ES, FM, MD, NO, LR. These are some tricks to remember the element present in the modern periodic table. Again, I want to say that these are not belongs to your course of study. It is just remembering the elements present in the modern periodic table. You can also make yourself some tricks how to remember the element present in the modern periodic table. But it is highly important to remember the elements present in the modern periodic table. Otherwise, you cannot say which element present in which block, in which group, in which period. You cannot also say the atomic number of the elements, the electronic configuration of the elements like this. You can face many problems regarding about the elements present in the modern periodic table. So it is bound to remember all the elements present in the modern periodic table. If you will remember the element present in the modern periodic table, then it is very easy to study about the inorganic chemistry. Next, I want to explain how to calculate the atomic number of an element. This is your modern periodic table skeleton. This is your first period. This is your second period. This is your third period. This is your fourth. Next, this is your fifth. Next, this is your sixth. This is your seventh period. Suppose an element present in the second period, you aim to find out the atomic number of that element. Just add 8 with the atomic number of the element which is present in the first period. That means when we want to go from first period to second period, then it is bound to add 8. From second to third period, it is bound to again add 8. From third to fourth period, it is bound to add 18. Fourth period to fifth period, it is bound to again add 18. From fifth period to sixth period, add 32. From sixth period to seventh period, it is bound to add 32. These are some tricks to find out the atomic number. Remember an important point for first, second and third group. We generally use extra trick, that is for first period to second period. We generally add 2. From second to third period, we generally use 8. Next, from third to fourth period, we generally use 8. From fourth period to fifth period, we generally use 18. From fifth to sixth period, we generally use 18. From sixth period to seventh period, we generally use 32. For other group. For other group means except first group, second and third group, we generally follow this trend. From first period to second period, we generally use 8. From second to third period, we generally use again 8. From third to fourth period, we generally use 18. For fourth to fifth period, we generally use 18. From fifth to sixth period, we generally use 32. From sixth to seventh period, we generally use 32. This trend is only for first, second and third group, and this trend is used for all the group except first group, second and third group. Now find out the atomic number of an element. The name of the element is polonium. How can I able to find out the atomic number of polonium? Recently we studied about the tricks how to remember the elements present in the modern periodic table. This is your group 13 element. For remembering group 13 element, generally we use a short trick, that is your Bal Gangadhar Indian Tilak. For 14 group element, we generally use chemistry sir gives short problem. For 15 group, we generally use a short trick, that is your नए पड़ोसी आशा जी से भी भिखारी. For 16 group, we generally use a short trick, उससे तेरा पोल खोल दूंगा. In this trick, polonium will come. For 16 group element, we use the short trick, that is your उससे तेरा पोल खोल दूंगा. Look at that. In this tree, here PO is written. This indicates that polonium. The group 16 elements are oxygen, sulfur, selenium, tellurium, polonium. Our aim to find out the atomic number of polonium. We know that the atomic number of oxygen
is 8.
Oxygen belongs to the second period. Our aim to find out the atomic number of polonium. Now find out the atomic number of sulfur. Sulfur present in the third period. When we come from second period to third period, generally we add 8. That means 8 plus 8, that is your 16. Next add 18 for selenium. That means the atomic number of selenium is 34. Next add 18. The atomic number of tellurium is 52. Next add 32 with 52. Then the result is 84. From this it is clear that the atomic number of polonium is 84. Next I want to find out the atomic number of potassium. At first I want to check all the tricks in which trick potassium belongs. Potassium belongs to the group 1 elements. For group 1 elements, the trick is your हेलिना का रूबी से फ्रेंडशिप. This letter K indicates potassium. The group 1 elements are hydrogen, lithium, sodium, potassium. Since potassium belongs to the first group, so we generally follow this trend. The atomic number of hydrogen is 1. The atomic number of lithium is 1 plus 2, that is 3. The atomic number of sodium is 3 plus plus 8, that is your 11. The atomic number of potassium is 11 plus 8, that is your 19. That's why the atomic number of potassium is 19. By this way, you can able to find out the atomic number of any one element present in the modern periodic table. Remember some important point: group 1, group 2 and helium are belongs to S block. That means I am telling about this and this. These elements are called S block elements. This is your group 3, this is your 4, next 5, 6, 7, 8, 9, 10, 11, 12. The element present in these groups are called D block element. So you can write group 3 to 12 elements are called D block elements. Except helium, the element present in group 13 to 18 are called P block element. This is your group number 13, this is your 14, next is your 15, 16, 17, 18. So we can write except helium group 13 to 18 are called P block element. The element present in the bottoms of the modern periodic table are called F block element. This is your lanthanide series. This is your said to be actinide series. These elements are called lanthanide series. These elements are called actinide series. This is your group number 1. This is your group number 2. Next, I want to explain the importance of group number of an element to their valency. According to the new IUPAC recommendation, these elements are named as group 1 element, but according to the old IUPAC recommendation, it is also called IA. This is your double IA, this is your triple IB, this is your IBB, this is your BB, this is your BIB, this is your B double IB, and these three group, that is your 8, 9, 10 group are called B triple I. This is your called IB, this is your called double IB, this is your called triple IA, this is your IBA, this is your BA, this is your said to be BIA, this is your said to be B double IA, this is your zero group. The group number of this group element is 1, that is your IA. It indicates that the valency of the element present in group 1 is your 1. Since the valency of group 2 element is your 2, so this group is named as 2, that is your double IA. Next thing about the group 13 elements, the valency of the element present in the group 13 is 3, so the group number is your triple IA. Here the digit 3 indicates that the valency of the element is 3. Similarly, think about the group 14 element. The group 14 element having valency 4, so the group is IVA. Here also the digit 4 also indicate the the valency of the element present in group 14 is 4. Look at that. Here 5 is written, here also V is written. Here 6 is written, here also VI is written. Here 7 is written, here also VII is written. This group is also called VIIIA. Here 8 is written, so we think about VIII. Here 5 is written, now think about 8 minus 5, that is your 3. So the valency of element present in group 15 is 3. The element present in group 15 also show valency 5. Similarly, think about the element present in group 16. It have valency 6. It have general valency, that is your 8 minus 6, that is your 2. The general valency of the element present in group 16 is 2. Similarly, think about the group 17 element. The group 17 element having valency, that is your 8 minus 7, that is your 1. That means all the element present in group 17 having valency 1. Some group 17 element also show valency 7. Next, I want to think about the group 18 elements. The valency of group 18 element is 8 minus 8, that is your 0. So the valency of group 18 element is 0. Next, I want to explain a good relationship between old IPAC recommendation and new IPAC recommendation. Look at that. The group number 1 have a good relationship between IA. We know that 1 means in Roman letter it is called I. Here I is written, here also 1 is written. Here 2 is written, in Roman letter it is said to be double I. Here 3 is written, 3 is considered as triple I in Roman letter. Look at that, here triple I is also written. Like that you can also think about IV4, B5, VI6, VII7. This is your exceptional case. 8, 9, 10 group combinedly called the triple I. Here I written, here 1, here double I written, here 2, here triple I written, here 3 is written, here I written, here 4 is written, here V is written, here 5 is written.
Like that, here VI,
Here 6, here V, double I, here 7 is written. The group 18 is also called VIIIA group. 8 means VIII in Roman letter. These are the good relationship between old IPAC recommendation and new IPAC recommendation. In these two group, letter A is present. In this 6 group, letter A is present. In between these 2 group and this 6 group, letter B is present. The letter B starts from group number 3 to group number 12. Next, I am going to explain how can you write the electronic configuration of any one of the element present in the modern periodic table. We know that the atomic number of sodium is your 11. The electronic configuration is your 1s2, 2s2, 2p6, 3s1. You can also write the electronic configuration of sodium like this. This is your neon 10, 3s1. Neon is the previous inert gas of sodium whose atomic number is your 10. Look at that. 10 plus 1, that is your 11. This is the other type of electronic configuration which can be written by the help of previous inert gas element. Suppose I want to take another example, lithium. The atomic number of lithium is your 3. The electronic configuration of lithium is your 1s2, 2s1. 1s2 belongs to your helium having atomic number 2, type of electronic configuration can be written by the help of nearest previous inert gas. The inert gas elements are helium, neon, argon, krypton, xenon, radon. To write the electronic configuration of any one of the elements present in the modern periodic table, it is bound to remember some general formula. For S block element, the general electronic configuration is your previous inert gas NS122. For group 1, the electronic configuration is your previous inert gas NS1. PIG means previous inert gas. For group 2, the general electronic configuration is your previous inert gas NS2. Suppose I want to write the electronic configuration of magnesium. Magnesium belongs to the second group. For second group element we know a trick, that is your beta Mangekar Santro Babrazi. The elements are beryllium, magnesium. The atomic number of beryllium is your 4. Magnesium belongs to the third group, so it is bound to add 8 with the 4. That means the atomic number of magnesium is your 12. The previous inert gas of magnesium is your neon. So at first write neon having atomic number 10. Magnesium belongs to group 2, so it is bound to follow this general electronic configuration. The previous inert gas is your neon. Next, I want to write the NS2. Magnesium belongs to the third period, so N is equal to 3. So here I can write 3s2. The electronic configuration of magnesium is your neon 10 3s2. Suppose I want to write the electronic configuration of barium. Barium belongs to the second group. The second group elements are beryllium, magnesium, calcium, strontium, barium. Calcium belongs to the fourth period. So the atomic number is your 12 plus 8, that is your 20. Strontium belongs to the fifth period. So atomic number of strontium is your 20 plus 18, that is your 38. So here I can write the atomic number of strontium is your 38. Barium belongs to the sixth period. So the atomic number of barium is 38 plus 18, that is your 56. So the atomic number of barium is your 56. Now I want to write the electronic configuration of barium having atomic number 56. Barium belongs to the group number 2, so it is bound to follow this general electronic configuration. The previous inert gas of barium is xenon, so it is bound to write here xenon 54. Barium belongs to the sixth period, so here N is equal to 6. So here I can write 6s2. Finally, the electronic configuration of barium is xenon 54, 6s2. 54 plus 2 equal to 56. Suppose I want to write the electronic configuration of an element belongs to the P block. For this, we generally remember a general electronic configuration for P block element. The general electronic configuration is previous inert gas N-2 M 14 N-1 D 10 NS2 NP126. This is the general electronic configuration of an element present in the P block element. This is your group number 13, this is your 14, 15, 16, 17, 18. For group 13 element, the general electronic configuration is previous inert gas n minus 2 f14 n minus 1 d 10 n s2 mp1. For group 14, the general electronic configuration is your previous inert gas n minus 2 f14 n minus 1 d 10 ns2 mp2. Like group 13 and 14, the general electronic configuration for group 15 is previous inert gas n minus 2 f14 n minus 1 d10 ns2 mp3. For group 16, the general electronic configuration is your previous inert gas n minus 2 f14 n minus 1 d10 ns2 mp4. Like that, you can also think about for group 17 mp5, group 18 mp6. Suppose I want to find out the electronic configuration of polonium. Polonium belongs to the group 16. For group 16, the general electronic configuration is previous inert gas n minus 2 f14 n minus 1 d10 ns2 mp4. The previous inert gas of polonium is xenon, so at first it is bound to write the xenon 54. Polonium belongs to the sixth period. Here n is equal to 6. Now put the value of n here. So it is bound to write 6 minus 2, that is your 4. So here I can write 4f14. Now put the value of n here. Then I can write 6 minus 1, that is your 5. So it is bound to write here 5d 10. Now put the value of n here and also here. Then I can write 6s2 6p4. Finally, the electronic configuration of polonium is xenon 54, 4f14, 5d 10, 6s2 6p4. The atomic number of polonium is your 84. Look at that. 54 plus 14 plus 10 plus 2 plus 4 equal to 84. Suppose I want to write the electronic configuration of krypton. What will be the electronic configuration of krypton? Krypton belongs to the group number 18. The general electronic configuration of group number 18 is previous inert gas n minus 2 f14 n minus 1 d10 ns2 mp6. The atomic number of krypton is your 36. The previous inert gas of krypton is your argon. So at first it is bound to write your argon. The atomic number of argon is your 18. Krypton belongs to the fourth period. So here n is equal to 4. Now put the value of n here. That means 4 minus 2. That is equal to 2. Here we can write 2f14. Remember, there is no 2f orbital. So here I cannot write 2f14. We know that the f orbital starts from n cell. That means we think about 4f like this, 5f like this, but we cannot think about 2f, 3f like this, because such type of orbitals are not present corresponding cells. Next, put the value of m here. Then I can write 4 minus 1 equal to 3d. 3d belongs to your m cell. Such type of orbital is present in the corresponding cells. So here I can write 3d 10. Next, put the value of n here and here. then I can write 4s2 4p 6. The atomic number of krypton is 36. Now check that 18 plus 10 plus 2 plus 6 equal to 36, which is equal to the atomic number of krypton. So this electronic configuration is correct. Finally, the electronic configuration of krypton is argon 18, 3d10, 4s2, 4p6. Similarly, by remembering the general electronic configuration of d block elements, we can able to write the electronic configuration of any one of the element present in the d block. Next, I want to do a question. Find the atomic number, group, period, block, and electronic configuration of arsenic. By remembering the tricks, we can able to find the group in which arsenic is present. Arsenic is present in group 15. For group 15, the trick is Nai Padosi, Asaji Sevi, Dhikari. So the group 15 elements are nitrogen, phosphorus, arsenic, strontium, bismuth. From the trick for group 15, that is the Nai Padosi, Asaji Sevi, Dhikari, we can able to find the group in which arsenic is present. The group in which arsenic is present is 15. According to the old IPAC recommendation, the group is VA. Here 5 is written, so the group is V. We know that the letter A is present from group 13 to group 18. So we can able to write the group is VA. This is your group according to the old IPAC recommendation. Look at that, arsenic is present in the fourth period. So here I can write period is fourth. Next, I want to write the block in which arsenic is present. Arsenic is present in the P block. Next, I want to write the atomic number of arsenic. Nitrogen having atomic number 7. Phosphorus belongs to the third period, so the atomic number is 7 plus 8, that is 15. So here I can write the atomic number of phosphorus is 15. Arsenic belongs to the fourth period, so the atomic number of arsenic is 15 plus 18, that is 33. So here I can write the atomic number of arsenic is 33. Finally, I can write the atomic number of phosphorus is 33. Arsenic belongs to the group 15. We know that the general electronic configuration of group 15 is previous inert gas N-2F14, N-1D 10, NH2, NP3. Since arsenic belongs to the fourth period, so your N value equal to 4. The previous inert gas of arsenic is argon, so here I can write argon 18. Put the value of N is equal to 4 here. I can write 4 minus 2 equal to 2. That means here we can think about the 2f14, but such type of 2f orbital is not possible. So here I cannot write 2f14. Now put the value of N is equal to 4 here. Then I can write 4 minus 1, that is your equal equal to 3. So think about the 3d10. This type of 3d orbital can be possible. So here I can write 3d10. Now put the value of n is equal to 4 here and here. So I can write 4s2 4p3. So the electronic configuration of arsenic is argon 18 3d10 4s2 4p3. Our question: find the atomic number, group, period, block and electronic configuration of arsenic. Atomic number of arsenic is 33. Arsenic belongs to the group 15, that is your Va. Arsenic belongs to 4th period. Arsenic belongs to P block. The electronic configuration of arsenic is argon 18 3d10 4s2 4p3. Next I want to do another question. Find the atomic number, period, group, block and electronic configuration of aluminium. By remembering the trick, we can able to find the group in which aluminium is present. The trick for group 13 is Bal Gangadhar, Indian Tilak. The elements present in group 13 are boron, aluminium, gallium, indium, thallium. From the trick, it is clear that aluminium belongs to group 13. The group 13 is also called IIIA. Look at that, aluminium belongs to the 3rd period. Look at that, aluminium belongs to the P block. Now I want to find out the atomic number of aluminium. The atomic number of boron is 5. Aluminium belongs to the 3rd period. So the atomic number of aluminium is 5 plus 8. That means 5 plus 8 equal to 13. So the atomic number of aluminium is 13. So here I can write atomic number of aluminium equal to 13. Now I want to find out the electronic configuration of aluminium. Aluminium belongs to the group 13. We know that the general electronic configuration for group 13 is previous inert gas N-2F14 N-1D10 NS2NP1. Aluminium belongs to the 3rd period. So the value of N equal to 3. The previous inert gas of aluminium is neon. So here I can write neon 10. Put the value of N equal to 3 here. Then I can write 3 minus 2 equal to 1. That means I want to think about 1F14. But 1F orbital is not possible. So I cannot write here 1F14. Now put the value N is equal to 3 here. Then I can write 3 minus 1 equal to 2. That means I want to think about 2d10. 2d orbital is not possible. So here I cannot write 2d10. Now put the value of N is equal to 3 here and here. So I can write 3s2 3p1. Finally, the electronic configuration of aluminium is neon 10 3s2 3p1. Our question: find the atomic number, period, group, block and electronic configuration of aluminium. The atomic number of aluminium is 13. Aluminium belongs to the third period. Aluminium belongs to the 13 group, that is a triple IA. Aluminium belongs to the P block. The electronic configuration of aluminium is neon 10 3s2 3p1. This is all about for this class. Thank you. Have a nice day.